Do you want me to present first, Tom?
Yeah, so we're live. So welcome to ONOS TST meeting. This is our first one after the ONF Connect event in middle of last month. This is a public and recorded meeting, and today's primary subject is how to handle device connectivity and spreading information about the device connectivity throughout the system. And Andrea is going to take the lead on this. So go ahead, Andrea. Oh, let me share do you want to share or do you want me to share the presentation?
I've taken over the presentation, thanks.
Perfect.
Thanks, Tom. So the idea was to discuss exactly what's the definition of state of a device. When I say state, meaning really connection. State, meaning if a device is connected or not connected, or like during connection state, because depending on the different protocols that the device might have and depending on the state of the device, different action could be taken at different points in time from different microservices within the ONOS architecture. So yeah, I'm going to talk about a little bit what I consider to be a device state, what I think should be and how this should be propagated, how to deal with multi-protocol devices, how to propagate the fact that the device is available or not, and then a little bit on a touch on the configuration state during the device connection. So the first thing is what is the state of a device? So part of this work is being based on a patch that I have on ONOS config. It's called device state, just to go take a look at it if you're interested. The idea is that I think there are 3 states in which a device it could be in, which is it could be connected. For each protocol the device has, it could be either connected, disconnected, or connecting. An important point that I make is that this connection state is referred to the gRPC service, meaning the GNMI, P4 runtime. It's not a layer 3 connectivity, and the topology has no direct connection with the device. So this device state is kept in Topo, but Topo has no direct way of assessing such connectivity. It has to go through the services that speak the protocol that the device has, in particular like config, GNMI, P4 runtime, control, for example. So what my proposal is to extend the device.proto file that is currently in topology to include these 3 states in an enumeration in order for all the different services, which we will talk about later, have the same object. Is that something that could be feasible? Do you guys see any other possible state for a device? Do you prefer this to be called available, unavailable, or?
Is the connecting state for
So the connecting state is something that I envision because there is a period of time out of which topology, so let me maybe jump to this thing. So between 1 and 6, that is the connecting state. Oh, well, 1 and 5. So the idea for the connecting state is that it's the point in time where a service is opening a connection to the device, during which, for example, we hit this problem in ONOS config, during which operations to the device might be or might not be applicable, and there might be race conditions for configuration on the device that you take in on board, but then you cannot really apply, so that the system gets in an inconsistent state. That is why I have that connecting state. It's like a pending state of a change.
Yeah.
Does that make sense?
Yes. Yeah, I think it's fine.
Tom, do you have any other?
No. I completely agree. I mean, I think it's needed because we need to be able to, even the system itself needs to know it, whether it's initiated a connection, but doesn't have one yet.
So what I'll do is then I'll put these three in an enum in the proto file and push that up into topo 2. So then that goes on how do you propagate the state. So the idea is that topo receives device information and propagates the device information to a service. Let's take ONOS config for now. The propagation happens after topology saved it in a connecting state. Because the first thing it's going to do is try to connect the device to one or many protocols. So ONOS config, the service, goes and contacts the device with a certain timeout. If the device replies or times out, the service goes back to topo, communicating one or two states, connection or non-connection based. So the device at point 5 can only be connected or disconnected. Then topology saves that state, meaning that it saves the fact that it's being connected instead of pending, or instead of connecting, or that is not connected instead of connecting, and also issues an event. And I think this is pretty straightforward, unless there are any objections to it. No? Okay. But this is a single device. The problem really arrives when there are multi-protocol devices. So a multi-protocol device is, for example, a Stratum device that has multiple protocols to which a service can interact with it. Meaning that, for example, with Stratum, it's going to be P4 runtime, ONOS control, ONOS config with GNMI, and maybe ONOS config, ONOS operations with GNOI. So what needs to happen is that a device needs to keep information about its state on a per protocol basis.
Right.
The question is, does it have to be on a per protocol or on a per service? Meaning that the device is being connected to ONOS config, or is it going to be connected to GNMI? It's a debate.
Yeah, that's a good question. Do we want to, at least as part of the ONOS core, kind of assign responsibility, like a primary custody for communicating with a device using a given protocol? So there's like an affinity of the service to protocol. I don't know. It seems like it might be simpler to do that, to kind of create that affinity and have a basically, ONOS config has the authority over GNMI, period.
Mm-hmm.
Because that could lead to, to some issues if you have other services communicating via GNMI in a write capability. I don't know if there is other use for multiple writers.
There might be multiple readers, maybe.
Right.
But
in that case, right? In that case, they wouldn't be reading. If they would be reading directly themselves, not reading through the config. Right. I don't know. Would they need to be maintaining the state in the topo? Let's do it this way. My suggestion would be, like, just to preserve flexibility, we can create the affinity kind of de facto, but for now, let's just map the device to protocol, right? So that it's more generic, gives us flexibility down the line, and we can sort of by convention establish the affinity, and then if you need to break it for some unforeseen reason. We have the ability to do that and are not left in this awkward position where the affinity is directly to the service.
Okay, so what my proposal for that is then it's going to be device and protocols, one to N, a device for one protocol.
Right.
And our device has many protocols, and for each is going to have a state. So I can put that into the attributes map that we have at the moment. We can come up with some naming conventions or something. I think that the state is going to be based on the enumeration, but there is really no definitive name for the service. I'm just going to use the protocol. Like, for example, it's going to be GNMI colon active, or sorry, connected.
Yeah, the question is, my question is about the use of the attributes here. Do we want to impose more of a type constraint? So basically the connection connectivity is stored separately from all attributes, and leave the attributes
so
kind of sparse notations.
The only issue that I see there is that you don't know how many attributes a device can have. You could use the repeated file of protobuf to have that, but it's still going to be a key value pair.
Yeah, no, it would still be a key value pair. I understand, but it just, yeah, I guess it doesn't really matter if it's in the attributes. I just kind of worry about kind of, because if everything then gets piled up in the attributes, that can kind of degenerate into a schema-less bag of properties.
Yeah, I would prefer to put it in a separate type-safe map that has that's specifically intended for device state.
Yeah.
Okay.
I would lean towards that, right?
And also, I could define an enumeration of protocols. That is because I think we're not going to have that many, meaning that you know that GNMI is going to be config, P4 runtime is going to be control. At the moment, we kind of have only these two. GNOI is a third one, and maybe something related to RAN, but at the moment we don't have it. So I could define an enumeration of protocol to device state enumeration, meaning that we have a more type-safe map that you could only write those kind of things.
Right, I think so. So that basically you have enum to enum mapping, right?
Exactly.
Yeah, let's go with that. Let's start more strict, and then we can, the protobufs can always be evolved forward.
Yeah. Okay. Perfect. That's fine by me. Then the question becomes, every service needs to upstream to tuple the state of its protocol for a particular device. So the workflow that we have seen for config before kind of happens for every protocol. But the question then, the first question is, when is the device considered to be connected? Because the problem is that you could consider a device connected with just one protocol, or if it's a multi-protocol device, either you need all of them or you need some of them for maybe initiating other types of connection. For example, this is something that I came up with Stratum. You could have just the GNMI connection, push this chassis config, and at that point start the P4 run, and then at that point Stratum could start the P4 runtime element. I don't know if this is the case, but it could be an example of when you could still consider a device to be connected for a protocol, but not the others.
Yeah, I think we ought to consider the protocols in isolation, the notion of connectivity of the protocols themselves. So there's no such thing as being fully connected. It's connected through GNMI or not. It's connected through P4 runtime or not. And
so is there a distinction here between reachable, which is kind of the layer 3, I can ping it, I can get to it, versus connected?
That is a good question. So I was discussing this with Sean, and Sean brought up this very good point. Do we care about layer 3 connectivity? Meaning that you could, as you said, David, reach a device, but not be able to open a service on it.
It might be useful for diagnostic purposes, yeah.
Yeah, that was my thought.
Okay, but then there is, this kind of breaks an important assumption that I've made, that our service is responsible for a protocol, and the topology does not have any direct connection to the device. If the layer 3 connectivity point is desired, then we need to find somebody that takes ownership of pinging the device.
I think that's what it says in the name.
Yeah, so the question is which service would be sort of in custody of maintaining maintaining the state, right?
No, well, maintaining a layer 3 state. So this
that's what I mean. That's what I meant. So basically, somebody has to be responsible for keeping up to date the state that corresponds to L3 connectivity.
Yes.
So if you recall from the kind of the architectural deployment architecture, we had these discovery agents sitting aside that were responsible for basically supplying information about devices. Clearly, information about a device could be specified from North or from an orchestrator, right, via an API. The idea here is that you could also have automated agents that would be sweeping the environment for devices, using whatever protocols, whether it's SLP, DNS, ICMP, ping sweeps, or things like that. So we could potentially just have an agent to do that. So I'll tell you what. Why don't we include L3 connectivity as part of the enumerated value?
Okay.
Right. And that way we have the flexibility of representing that for diagnostic purposes, because it might be useful to know that, let's say that if L3 is established, but for some reason GNMI can't be, then, or P4 runtime can't be, then there might be some issues with either certificates or the endpoints are not started on a device and things like that.
Yeah, what we could do is that in theory, or well, in practice, for example, ONOS config could also be responsible for a layer 3 connectivity, because if you can open a gRPC service, it means that you definitely have connectivity to it.
Yeah, but the problem is then I think that might be fine, but we would have to then also figure out what about P4 runtime, right?
Yeah, no, absolutely. What I'm saying is that I'll definitely include it in the enum.
Yeah,
protocol enum.
And we can decide where we place the custodian. Sure, let's do that.
Exactly.
Okay.
Exactly.
Got it.
Perfect. Also, so I think this settles the first question. We settled the second question, meaning that there is, we decided that there is, each protocol goes kind of on its own. We have this enum with this map with these enums, and anybody who's interested in config sees if it's connected via config. Or if anybody's interested in control, sees if it's connected to control. That's it. So question number 3, which is, do we want or need a notion of a required connection to a device? I think the reply is no. You go on a per protocol basis.
Right.
If a service has a required important connection, it checks that connection. If it's connected, it goes forward. If it needs all of them, it checks all of them.
Yep, exactly.
Okay.
Like ZTP might require all of those services being available, right?
Yeah. I'm taking some notes. Okay, perfect. So there are a couple more. And I think the first one here is already settled by the discussion we had, because when does Topo propagate a connection event? Since we decided that each protocol goes kind of on its own basis, basically Topo will generate a device updated event every time it gets a signal from a service about the connection of a protocol, meaning it is option A, an event per protocol.
Yes.
Yeah, so this should be an easy change. I mean, if we just add once we just add the enums, this is already the behavior. So
Yep.
Yes, yeah, no, I know. I was just discussing the possibility of aggregating, which I think could be interesting, but it also could be done at the service level. And if we see that many services need this, we could provide two set of APIs to do it, meaning that for now we do one event per protocol, but if a service requests availability of multiple protocols, we could open up an API from Topo to buffer the events up and signal it only when all of them are done.
Yeah, this is very similar to the problem we have in today's ONOS with the network configuration, right? When you have when you have an application that requires multiple configurations, and right now they have to handle the complexity themselves.
Yes.
Okay. Yeah, no, that sounds reasonable. For right now, let's do it per protocol. We can add the aggregation capability later if there's need for it. Yep. Within the topology subsystem.
Perfect. Then a very good question, which was raised by our discussion with me and Sean, is that the service instance mastership, meaning that we will deploy many instances of a service. Thus, somebody has to tell Topo about the connection of a device. Let's say that instance, an instance of a service propagates information about the device state to Topo, but then fails. Does Topo need to know that the mastership of that device changed in terms of instance of a given service, or should this be opaque to it?
yeah, I don't think it needs to know, because that should be handled by the services where the actual mastership is
Exactly,
handled.
that's about the services amongst themselves, right?
Yeah, I'll make client connections to Topo, and it just, all it cares about is that it got a connection from some client, and mastership is just defined by whatever client decided to request something from Topo.
Okay. So the question is, do we need to do some sort of a reference counting? Example being, let's say we have two instances of ONOS config. One of them signals that it has a connection to GNMI to device A. The other one signals that it also has a device A connection via GNMI. And then suddenly the original instance says, oops, I lost it for some reason, right? Because let's say something happened on the network path or whatever fault happened, and it no longer has the connectivity. And it signals that to the Topo that it lost connectivity. There might need to be some sort of a source-based reference counting.
Well, it depends. So the question is, let's take config as an example. If we deploy 5 instances of config, are all of those 5 instances going to open a connection to the device or not?
I guess, yeah. In the case of config, perhaps not, because we may have sharding based on a device. But in case of P4 runtime, I'm not sure, because we may want to have a fast failover for flow rule programming and things like that. So there may be more.
Yeah. So P4 runtime, as I understand it, multiple servers will connect to the device.
Right.
Or clients, I mean, will connect to the P4 runtime server. Yeah, in config, we plan on having 1. So, but there's a pattern. If we need to resolve the potential for requests going from a bunch of places to Topo, there are patterns, which is just fencing in the Topo API that we can use. I don't think we have to build the notion of mastership into it, but we can, if we need to, we can build a sort of versioning, just add basically a version number for client requests to the Topo API, but I would delay that.
Right. So I didn't mean to imply that we should introduce versioning. I'm sorry, we should introduce mastership into this concept. I don't think we need to mix it in, but we need to have a notion of whether all of them or just some of them are connected. And so if the question is with regards to just general connectivity via P4 protocol, that's going to be a yes or no question. And we need to figure out when do we want to answer yes and when do we want to answer it no. My thought was we want to answer it yes as long as one of them has a connectivity.
Well, even in the case of the P4 runtime, even if multiple clients are connected to the P4 runtime servers, there's still just one master for a device. And so that should still be the source of truth for what the state is, in my opinion, because that's where requests are coming from.
I see. Okay. I see. Okay. So basically the mastership would be kind of upstream, would be used to determine whether or who sends the event about the connectivity.
Yeah, I mean that's what I would think, but
yeah, I would agree with this. Basically, there is
I see
that the event of connectivity is issued from a service master. If it's just one instance because it's an active passive scenario like config, meaning that the passive one is not even connected, or a master in case of mastership.
I see. So for protocols that support multiple different clients connecting at the same time, the notification about the connectivity that's sent to the topology service or reported to the topology service needs to be delayed until the mastership has been established.
Mm-hmm.
Yep.
Okay.
Okay.
And
I think that's fine.
Yeah, clearly, okay, that may be a detailed implementation. We need to figure out also, when, for example, when the last master, yeah, well, that's a detail we can deal with it.
yeah, we can think about it.
There's other cases that I was going to bring up, but that might easily take the whole meeting. I think it's important that just we have an agreement, then enough values, separate, storing the information in separate map, not introducing the notion of mastership into this, and reporting the events on per protocol basis.
Yes, absolutely. And that we introduce a layer 3 notion.
And layer 3, yes. As a separate.
But that is like
kind of connectivity, right? Yeah.
Yeah, exactly. So the last element that I wanted to discuss, at least in my proposal today, was what happens to configuration during connection. Okay. So the problem is that there are two clear-cut boundaries. When a device is connected, we can apply a configuration to it. It goes down, it applies to the device. That's it. When a device is disconnected, we ONOS config accept the requests and says, watch out, the device is disconnected. We're going to apply it when it's connected. When it connects, when it shows up. Where the boundary is not so clear is when the config arrives during a connection. And there are kind of two possible approaches. It's written 3, but it's actually 2. So either we accept the configuration and apply it when the device signals its connection. And if the connection fails, we issue a rollback of that change in our store internally. Or we put configuration on block during connection phase and basically deny every request. I think these are the two options. If there are some others, I'll be open.
And any write request, anyway.
Yes, indeed.
Yeah, it feels weird to me to basically enqueue requests when a device is disconnected, and then when we're in the process of connecting to it, start rejecting or what is? I mean, it feels like if a request is received while connecting to the device, it should behave the same way as if the device were disconnected. I mean, in the event that the connection failed, basically the state of the device never reached connected, so you can never actually interact with the device. It should basically behave like the device was just disconnected.
Yeah,
Um,
I agree with that. I do agree. Because connecting is effectively just an extension of the disconnected state.
Yes, which means it shouldn't even be rolled back. It should just keep continuing like a request would if the device were just disconnected the whole time.
Okay.
So in this case, it's going to be acting like how I communicate to a device as opposed to like pre-provisioning in a management system. Because pre-provisioning in a management system, I can push all configuration all day long, even if the device doesn't exist.
No, I mean, we have that capability already. The only problem that we have seen is that we were trying to push information during a device connection, and then we were seeing strange behaviors where the system was in an inconsistent state. So what I gather from the discussion here is that we will need to behave in a way that we accept every change, and the device is connected or connecting. We don't try to apply them. We hold until the device is being in connected state, and we push it down.
Yeah, I think the reason we saw that before, Andrea, is we didn't have the connecting state, and I think now that we've represented it, we're in a better position. And I think I agree with Jordan's summation that it would appear very odd if it's disconnected and we accept changes. Why would they stop suddenly when we're in a connecting state? I think I'd agree that doesn't look right. So I think option one is what people are proposing, is it?
Yeah, but no rollback.
Correct. Yeah, in the same way as rollback wouldn't be supported if you were disconnected and subsequently tried to connect.
Yeah, you would have to figure out something to change that device configuration and send it back down again.
Yeah, and I mean, where the ONOS config is the master of the configuration.
Let's say, as David was saying, you pre-provision a bunch of things down to the device when it's not available. You pre-provision a set of things for a device which is not available. Then it tries to become available, but something wrong happens when ONOS config tries to push down that pre-provision state, pre-provision configuration. Then you're lost. There's nothing you could do. Somebody else needs to come in and change parameters for that device and reapply the config.
Yeah. I mean, there's always a risk of physical failure. I think the configuration system is the master, and basically it has to try again, or somebody has to intervene to fix it, to fix the device.
Yep. The only issue is that we might have to come up with a solution for the case where there is a bunch of configurations saved in ONOS config. We try to apply to the device when it's connected, but the device refutes it. The problem is that then you would have to go in and re-request a complete application of the config. This is something that we don't have at the moment.
Yeah, because at the moment we're sending down deltas by comparing the device's config and what we have as the config. And sometimes it may get twisted, and you have to do a configuration resync down to it to straighten it out. So yeah, maybe it's we don't have that supported at the moment. That's correct.
Yeah, I think that is needed. Basically, I'm not going to trust you in any case. Apply this and be done with it. Yeah, I think that's important. Okay, then it's option one without the rollback. Okay.
Yeah, there may be a place for like an administrative rebase operation.
Yeah.
I guess we can work with the Strand guys to to get a working model of that. What will that cause any upset for them if somebody tries to rebase or reconfigure?
Right.
Okay. That was all from my side. I think we settled all the points that I personally had on today's presentation. Those my thoughts. I think we agreed on the plan forward for this. I already have a patch for this that is started doing some of it. I have the capability to push back to topo information from ONOS config, for example. I need to augment it with the enumeration and also move it to, it's currently sitting in the attributes of the device. I need to move it to a proper map. So those things I can easily do. And then I'll summarize some of the decisions that we have made today in the design document so that are fixed for future discussions. So when P4 runtime, for example, comes up, we don't have to have this discussion again. We just get that and apply it to the implementation that we are going to do for control.
Yep, that sounds good.
Okay.
That's great. So I think that concludes this topic, right?
Yes.
All right. Does anybody have any other topic to discuss while we're here? If not, then I think we can call it a day. I'll upload this recording shortly. And we'll see everybody in 2 weeks.
Thanks. Thanks, everybody.
Everybody.
Take care.
Bye-bye.
Bye-bye.
Bye.
So,